So we are doing NPNEIAIS ECB.
It's not so easy.
L D.
Where did the L and D come from?
G P S.
There's so much going on right now.
Okay. We are at the end of Unit 2. Okay. We're at the end of Unit 2. You have a test next week on Thursday. Okay. You have a test on Thursday, and you have to be able to do and explain why all these things. So let's go through. Level 1 was NPNE, right? N is its name. This is sulfur. There are 16 protons because 16 is the atomic number. It's the bottom left number. This is in ion notation, right? You need to know. You have to be able to identify, is this ion, isotope, or periodic table notation? Then you have that written on your formula sheet. You should anyway. So there are 16 protons. In this problem, there are 17 neutrons. Because it's 33 minus 16. There are 17 neutrons, right? There are 18 electrons because it's 16 minus a negative 2. There are 18 electrons. That was level 1, NPNE. That was 2.1, NPNE.
I need to go on doing that.
Okay. Level 2 was IAIS. The first I is it an ion? And this is yes because it has a charge. It has a charge up here. So is it an ion? Yes, it is because it has a charge. The A stands for the AAM, and that comes straight from your periodic table. So you find sulfur. Sulfur is supposed to have a mass of 32, right? 32.07. If it's supposed to have a mass of 32, but I have a mass of 33, that means I have an isotope. Because 33 does not equal 32 like it's supposed to. Okay, remember an isotope question says, are they different? And you have notes on all of this. Therefore, it is not stable because it is an ion and an isotope. Here, this level, you're identifying what kind of atom you have. Do you have a regular, everyday, good old-fashioned atom that doesn't have a charge and has the right mass? Or do you have an ion, or do you have an isotope, or do you have something that is both? Okay? Then the EC, the electron configuration, is based on 18 electrons. And last time, I showed you, or a couple times ago, follow me on this.
Don't drop the story.
I showed you how to get the electron configuration from the periodic table. And remember, these are the shell numbers, the sections, right? This is your S section, this is your D section, and this is your P section. So when you fill, it's like filling a waffle with syrup. 1S fills 2. 1S, 2. 2S fills 2. 2P fills 6. 3S fills 2. And because I'm going all the way to 18 electrons, 3P fills 6. So that's your electron configuration. Your electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6.
If I was doing online, I saw that, I'd be so confused.
Okay. 1s2, 2s2, 2p6, 3s2, 3p6. Now, when we first started doing this, we did the EC math, right? And as a little sidebar over here, the EC math, for those of you that still like to do it that way, we started with 18 electrons, and you follow that little chart, that pathway on the back of your periodic table, and it says the first place we go is 1s, and 2 can sit down, because s's will only hold 2. And now I have 16 people to seek. They go then to 2s, and 2 can sit down, and now you had 14. They go to 2p, and 6 can sit down. Now I have 8. They go to 3s, and 2 can sit down. Now I had 6. And those 6 go to 3p. And that was the EC math. And that's how we first learned how to do the electron configuration. Because the electron configuration is hidden inside the math. 1s2, 2s2, 2p6, 3s2, 3p6. That's the written directions of where the electrons go. Then we had the Bohr model. The Bohr model was like an actual seating chart in a stadium. You have 16 protons and 17 neutrons like players on a field. And then you have these shells, and again, on the back of your periodic table, there's a diagram that we labeled. So in the S section, right? In the S section and the P section, you literally marked on a map where people were sitting. And there were 2 on shell 1 in the S section, 2 on shell 2 in the S section, 6 on shell 2 in the P section, 2 on shell 2 in the 2 on shell 3 in the S section, and 6 on shell 3 in the P section. And that was the Bohr model. The Bohr model was an actual map diagram of where the electrons went. Where are they sitting based on what you said they were sitting at. Then we had a loop diagram. And a loop diagram was a Bohr model that was squished, where all we looked at was the total number on each level. So we had 16 protons and 17 neutrons, but then shell 1 had a total of 2, shell 2 had a total of 8, and shell 3 had a total of 8. It is literally how many people are sitting in the first row, in the second row, in the third row. It's the total number. Okay? The dot diagram is the symbol with its valence as dots. And its valence was written at the top of your periodic table. And this is group 16, and above it we wrote how many valence it had, and you circled it. And that should have a valence of 6. And the rule for dot diagrams said that you needed to put them in little groups of 2 around the symbol, but you could have had 6 dots in any configuration as long as they were in little groups of 2 and as long as they were only on the sides. You couldn't put them in the corners or anything like that. You had to put them on the sides. That's the dot diagram. It is literally based on what element you're playing with and how many valence it had. The G stands for the group. It is in group 16. And if that group had a name, and we wrote 5 of those on the bottom of your periodic table, if that group had a name, we would include the name there, but this one didn't. The period is what row is it in? It's in period 3. And its state is the color coding. So if you find sulfur and you match your color coding, that is a non-metal. That is all 4 levels.